this is section 5.4, problem number 37. We're going to again use the fundamental theorem of calculus part 2, which is, again, the integral from a to b of f of x dx is equal to big F of a minus big F of b, where big F prime is equal to little f, meaning that big F is the antiderivative of little f. So, we are looking for, first and foremost, a function whose antiderivative is cosecant cotangent. I believe that function is negative cosecant of x. How can we check our answer? Well, we could take the derivative of this. Do we get exactly that? Yep. And so I'm going to evaluate this from pi over 4 to 3 pi over 4. And that's going to be negative cosecant of 3 pi over 4 minus a negative cosecant of pi over 4, superplus there. I'll need to know what the cosecant of pi over 4 is. I believe the cosecant is hypotenuse over opposite. So this becomes, well, this cosecant pi over 4 becomes root 2. Now what about the cosecant of 3 pi over 4? 3 pi over 4 is going to put me in the second quadrant, where sine and cosecant are both positive. And again, we'll have a root 2. So I've got negative root 2 plus root 2. That adds up to me to a big old 0. That's what they say the answer is. But they also would like us to check using the calculator. So let's go over to the calculator. And we will put in shift plus from pi over 4, tab to get up there, to 3 pi over 4, down here, trig to get over to cosecant of x, close that, multiply that by cotangent of x, and then tab to get over, oops, just to get there. Do I have that put in correctly?
Yes, sir.
Looks good. Enter, and we also get a 0 back.
Look at that beauty.
Any questions? Yes, Eli.
Yeah. Do you like when you have
Do you want this calculator screen or do you want the other screen up?
the other screen
All right.
for when the function inside the integral when you're trying to find the antiderivative of it and it's not like you gave us the exponent rule or so that.
Okay. Right now we're in a situation where you only have some. Our strategies are only that we're essentially recognizing them to be derivatives that we know, or we got an exponent, not an exponent rule. We've got a power rule. In the next chapter, we're going to explore doing antiderivatives that are more complex. But right now, we got to crawl before we walk and walk before we can run.
So you just like look at that and recognize those.
Right now, this section says look at it and recognize it. Right? All right. Done with this? Okay.